Hello, everyone. Today we're going to solve the LeetCode question, length of the last word. Now, this one's pretty, I want to say pretty straightforward if you are familiar with the certain library, cctype. You don't have to use this library. You can always use ASCII characters if you don't know this one. But this is just kind of a convenient way to solve it. But let's go ahead and see what it's asking of us. So given a string, so any kind of sentence essentially consisting of words and spaces, return the length of the last word in the string. Okay, and then we can see how it defines a word. A word is the maximal substring containing of non-space characters only. Essentially, it's saying that if we have, it says non-space characters, so it should technically include digits, but since these are words, they're not really going to include digits. They're only going to include alphabet characters. So we can imagine in this test case that says hello world, the last word says world, which is length 5. Right, pretty straightforward for this one. What about spaces? Fly me, spaces, to excessive spaces, the moon, and then excessive spaces at the end. Notice we kind of disregard the spaces. We just use them as separators to be able to tell which word is which. Here we have moon being the last word. So that's 4 letters, and that's why our output is set to 4. And then I think this test case is pretty interesting just because I'm a big One Piece fan. So here, Luffy is still Joy Boy. We could see that the last word here is 6 characters long, so or length 6. So that's why the answer is 6. Now, in order for this approach to work, I found it easiest to. There's actually, let me just start by saying there's many different approaches for this answer. We're just going to tackle one straightforward approach, which is finding the first word length. So if we know how to find the first word length, we know how to find the last word length. So I just think to kind of remove some of the complexity initially, we're going to go ahead and learn how to find the first word. And then afterwards, instead of iterating through the string forward to find the last word, all you have to do is iterate through the string backwards. That's really it. That's all the logic you need to change. Just because some of the main things that we have to consider are the word's not going to start right at the beginning. Sometimes there's going to be spaces which we don't want to count as part of the length. So for example, we're going to reverse these test cases so that here I'm finding the word hello, which is still 5 letters. Here, this is going to be fly, which is going to have 3 letters. And then this is going to be Luffy, which is going to have 5 letters. So those are the test cases we're going to use. And then we're going to go ahead and just change it up to reverse it to get the actual solution. So let's look at the actual programming logic. So number 1, once again, I just kind of covered, these are just some notes. The easiest way to tackle is to find the first word approach and then just traverse it backwards. Change from traversing forward to backwards, and then that's pretty much your answer. Now, how do we find it forward, right? Because that's really the key. Well, we need to know when to start counting. We need to know when we have found the first word, because what if there's initial blank spaces? We don't want to start counting. So we want to consider anything that's not an alphabetical character, right? Like a space or a digit or something. There's not really going to be digits. It says there's only going to be English letters and spaces. So we don't really have to worry about digits or anything. We're only looking for when there are alphabetical characters. That's when we start the flag. That's when we start counting. So we want to have a flag that says initially, we don't want to start counting until we find the first letter, essentially the first alphabetical character. Okay, that's step 1. And once you find that, you can go ahead and change the flag from false to true. So we know we can start counting at that point. Now, in this case, you can use a counter, which completely works. I'm going to use a temporary string to store essentially the first word. So in this case, I'm going to store the word fly. I'm going to store the word hello. I'm going to store that. And then at the end, instead of just returning the word, because I don't really need the word, I can go ahead and return the size of the word. It's equivalent to counting the values. I just feel that this is a little bit better, just because if you also want to know what the word is, then this way you can have access to that. And you also know the size. So you know the word and the size, versus if you only kept track of a count, then you only have access to the length. So a little bit less data, which is fine if that's really just the only use case, but just kind of wanted to extend the functionality a little bit. So once we know to start counting, go ahead and continue counting while we find, so step 3, once our flag is set, so once we know we started counting, any additional letter, any additional alphabetical letter is going to be counted or added to our temp string. And then lastly, once we spot a non-alphabetical character, like a space, And we know that the word has already started because we set our flag to true. That means we stop. So in the example of fly, we can see that we started at F, we added F, we added L, we added Y. And then as soon as we hit something that's not an alphabetical character, like this blank space, we're going to go ahead and say stop counting. We're just going to stop it there. So it's just going to be this word fly. And then the last thing is, once again, since we can return the count, which is essentially the size of the temporary string. So let's go ahead and go through this example with the string fly me to the moon. Notice there's spaces at the front, and we have essentially two variables to keep track of. The flag that determines whether we've started the word. Initially, we assume we haven't started the word yet, and then also an empty string. So we're going to go through it forward for this solution, and then once again at the very end, we'll just go ahead and reverse it. So for the first character, we can see that it's a space. It's not an alphabet character, so we're just going to ignore it. We're not going to set our flag to true because it's not an alphabet. Here we could see also again a space, so we're not going to change our flag. And then here again, this third space, we see it's not an alphabetical character, so we're just not going to change it. It's only until we get to the F that we know that we've started the word, and so we can go ahead and change our flag to true. We can also go ahead and add that letter to our temp string. So here's F. Next up, I see another letter, and notice I have a letter and also I've started the word, so I can go ahead and add that to my L. And then I see the letter Y, which is an alphabet character, and I know that this flag is set to true, so I can go ahead and add that. And then lastly, when I see a non-alphabet character like this space, but I know I've already started it, that's when I'm going to stop. I'm going to go ahead and exit prematurely from my loop. I don't have to finish the rest of the string just because the rest of the words are irrelevant. And that's the word that I needed. If I return the size of this temp string, it'll give me the size 3. And that's really just the approach. In order to do this for the actual problem, we're just going to go ahead and start iterating through the string backwards. So we'll just set up our for loop so that it traverses the string backwards, which is really just one change in the line of code. Now, the other thing that I wanted to mention is the library to be able to kind of do this with ease is cctype. cctype will have access to a number of different functions, which are pretty convenient. So for example, I can have the isAlpha function. It'll take in a character and it'll tell me, it'll return a Boolean. It'll return true if the character that I put inside of as an argument is an alphabetical character. So like A through Z, whether it's uppercase or lowercase. I also have like is lowered, checks whether my character is lowercase, English word, uppercase English word, checks whether it's a digit, and so forth and so forth. Let's go ahead and see it in action. So let's say, for example, that in this case, I have the letter J. I want to check if it's an alphabetical character. Well, it is. So it's going to go ahead and return true. So remember, this is true essentially. As long as it's not 0, it's true. If I were to return, like, let's say 7. If I were to say the letter 7, is that an alphabetical character? That is not. It is, however, a digit. So I could check if it's a digit, and then that should give me true now. All right, so there's all of these kind of fun different functions to play around with. It's very useful. They just map to ASCII characters, so technically we could create these ourselves, but it's kind of much nicer to just have these available. So now that we understand how that works, let's go ahead and start problem solving this. So once again, what do we need? We need our flag. We need to know whether we have started our word, and by default, we have not started counting. We haven't found that initial alphabetical character. The other thing is we're going to have our temp word. So this is our temp, and it's set to an empty string. So it uses the default constructor, so that's empty. Now what we're going to do is we're going to go ahead and iterate through our string. So we're going to go letter by letter, right, or character by character, and we're going to iterate through the string container. And there's a few different conditions to consider. We want to consider when should we change our flag. So when we haven't started counting yet, and we see an alphabetical character, that's when we change the flag. we change the flag. So let's go ahead and just write up this condition. We'd say if the current letter is a letter of the alphabet, and we have not started our word yet, then we know that we just started our word. So we're now able to start our word. We can also go ahead and add that letter to our temp. And then since we've already added the letter, that's all we want to do for this iteration. Let's go ahead and skip it. And we can kind of merge this later on with other pieces of logic, but I just kind of want to show the 3 different conditions. So this is when we find our first alphabetical character and kind of start that process. Next up is how do we keep adding to it? So for example, with the letter L. So if we've already started the word and we continue to see alphabetical characters, then that's when we want to keep adding it to our temp, the letters to our temp string. So if we see alphabetical characters, and we have started the word, add the letter to the temp string. Okay. So if we've started the word and also it's an alphabetical character, then we want to go ahead and add that letter to our temp string. All right, so that one's pretty straightforward. What's the instance in which we stop? The instance in which we stop is if we have started the word, and we see a non-alphabetical character. So in this case, a space, right? So non-alphabetical character, just by the constraints of this problem, it lets us know really we can only have alphabeticals and spaces. So it just depends how you phrase it, but this is just so that we can kind of extend it to also catch maybe like digits and stuff like that. So if we see a non-alphabetical character, then we should stop counting, stop adding, stop the loop, essentially, stop the loop, just because we don't want to add any further to our temp string. We're kind of done at that point. So if we have started our word and it's not an alphabetical, is alpha letter, it's a lot of parentheses. Then what we want to do is we want to go ahead and break out of here. So once again, if we've started and we know that it's not an alphabetical letter, we want to go ahead and just end that process. We got our word. We know exactly what it is. And then the other condition to consider is if this loop were to terminate, then we also finish, right? So if we get to the end of the string, let's say it's a 1-word string, then we kind of cut it off once the loop ends, right? So it's either we get kicked out prematurely or when the loop ends. So that's really it. And then the last thing we want to do is now that we have our word, we can go ahead and we know that at this point, temp contains the first word. So we can go ahead and return the size of the word, and that's the same as the count of the word. So if we were to run this with the different test cases, let's take a look. Let's see if this approach works. So here you can see we get an output of 3 for fly, which is what we're looking for. Let's look at case 1. Hello is size 5. And then also Luffy is size 5. So this looks good in terms of finding the first word. How do we go ahead and manipulate this so that we can find the last word? Contains the word. So once again, this approach is for iterating through it forward because we're using the for each loop. Instead, we're going to have to use a standard for loop because we need to use indices to traverse it backwards. So we're going to go ahead and say for int I is equal to s.size minus 1. So we're starting at the last index. We want to continue while our index is greater than or equal to 0. And let's go ahead and not make sure to decrement, otherwise you're going to kind of get out of bounds. And in order to make this solution continue to work, we have to use letter, right? So we want to be able to use that character letter. So we're going to go ahead and create the temporary character letter and say that that's equal to S at the index I. Essentially, this is how we get the current letter from the string. And just like that, now we can go ahead and submit this answer. And we should be able to see it run. Yeah, there we go. So it looks good. I hope that made sense. Please let me know if you have any questions in the chat. Please let me know also if you have any recommendations on how I should be kind of recording these videos. I try to do them as best as possible, and not necessarily as succinct as possible, because I want to make sure that people from all levels feel comfortable with these approaches. Just because when there are kind of solutions or tutorials that kind of go a little bit too high, a little bit too advanced, then I feel like it kind of deters people away from those who are kind of like starting their career path. And so I just want to make it as accessible as possible. That being said, these videos tend to go on a little bit longer, but I do hope it's appreciated. Let me know if you have any recommendations. But thank you for watching. We'll continue with more solutions. If you haven't already, please like, share, and subscribe, just because it does help the algorithm. And thank you for watching. I hope you have a wonderful day.